Overloaded constructors. My name's Caila Blanton. An overloaded constructor occurs when multiple constructors in a class have different parameter lists. Overloading constructor allows different arguments to be accepted when creating an instance of a class. Hotel. This is an example of a UML diagram for the class hotel. To begin with, we declare our instance fields, HName, which is a string, roomNum, which is an int, and numStars, which is a double. All of these are private. We then declare our constructors, hotel, which accepts no arguments, hotel, which accepts a string name, hotel, which accepts a string name and int rooms, hotel, which accepts a string name, int rooms, and double star count. We then have a setName and getName methods, setRoom and getRoom methods, and setStarCount and getStarCount methods, and a toString method. So here we've created the class HotelDemo to demo our hotel objects, and we've already imported java.io.asterisk and java.util.asterisk up at the top. And we've declared our class here, HotelDemo, and we've also declared our main method. Within our main method, we've declared the instance fields of a double, int, and a string such that we can read in the room numbers, number of stars, and the name of the hotel from the reader. We've also already created a scanner object keyboard, and we've already asked the user for a hotel name, number of rooms, and number of stars. So now we're going to create a new hotel object up here at the top. So hotel will be the name for our object, equals new hotel, and this time we're going to call the no argument constructor. This means that when we system.out.println hotel.toString, calling the toString method, which has already been created in our hotel class, it should print out everything. We'll make a new hotel object, hotel1 equals new hotel, and we're going to pass to it in name. And that will be calling our single argument constructor. So to show this, system.out.println hotel1.toString, and see we're keeping these separate so that when we call toString, we can see them all separately. And then we'll make a third hotel object, hotel2, and this time we'll pass to it both the name of the hotel and the number of rooms such that we can call our two-argument constructor. And we'll print this one out as well such that we can see that it really is calling that constructor and it is passing to it the name and the number of rooms. And now we'll call our descriptive constructor by making a fourth hotel object. And we'll pass to it in name, in room, and in star. And that way we can also see that the descriptive constructor also works with the toString method. And now we're going to compile hoteldemo.java. And then we're going to run it to test all of our constructors. So our default constructor named our hotel hotel. Our number of rooms were set to 50, and our star rating was set to 2.5. Now we're going to enter our own hotel name, and we'll call it Days Inn. As you see, it changed the hotel name to Days Inn, and used our default numbers for the number of rooms and the star rating. And now we'll enter the number of rooms. So we're going to change that to 34. And as you see, the number of rooms is now updated to 34. And it used our same input for the name. Now it asks us to enter the number of stars. 5. And so you see that our hotel name is Days Inn, our number of rooms is 34, and our star rating is 5. Now we're going to attempt to run the same program with non-traditional data. This will allow us to call the set method for star count and employ the data validation within. So let's run it. Going to use the same hotel name, Days Inn, and the number of rooms will be 75, and the number of stars will be -12. And see, it works. Designated constructor. The constructor with the most detail is considered to be the designated constructor. The other constructors can be defined to call the designated constructor. This is an example of a designated constructor. This constructor employs data validation through calling set methods. In it, we pass a string n, an int num room, and a double star rate to the constructor hotel. Within the constructor, we call set methods that track the data. Set name sets the name to the string that was passed to the constructor. Set num rooms passes num room, which was passed the constructor. And set rate uses star rate, which was also passed the constructor. The following is an example of a no-arg constructor. This constructor sets instance fields for Days Inn with 30 rooms and 2.5 stars. This is an example of a single argument constructor. This constructor accepts the string hotel name. The number of rooms is set to 1 and the star rate is set to 0. In the example, we pass to the constructor hotel the string n. Hotel, it then calls the hotel constructor with passing to it in 1 and 0. The default is set to at least 1 room and 0 stars. In this example, we have declared the class hotel. This is where the constructors called in hotel demo were derived. We have begun by creating the string variable hname, the int variable room num, and the double variable num stars. We then have a basic outline for each of the constructors we are going to create, and the methods set name, set room num, get room num, set star count, get star count, and toString, in which each of the variables is combined in a single string. To begin with, we will create our no-arg constructor. In this case, we will initialize each of the variables. So our hname will become a basic name of hotel. Our room num will be an average number of hotel rooms, such as 100. And our num stars will be an average number of stars, which would be 2.5 out of 5. Now we will create the single argument constructor. This constructor will accept the single argument of a string. We've named the string name. When we create the single argument constructor, we have the option of passing what was passed to the constructor to the designated constructor. In this instance, we'll call the designated constructor by saying hotel name, because that is the first thing that gets passed. Room num will initialize to be 50, and num stars will be 2.5. To create our two-argument constructor that takes a string name and an integer num rooms, we can use our set name method and set room num method. So set name will be name passed to it, and set room num, we will pass to it num rooms. Now we are going to create the definition for the designated constructor. We started off declaring public and hotel, and we've passed to it the string name, the int num rooms, and the double star count. Within this constructor, we are going to employ some data validation. We'll do this by calling the set methods. So set name, and we'll pass to it the string name. Set num rooms, and we're going to pass to it the string num rooms. And set star count, and we're going to pass to it star count. We are going to now employ some basic data validation. In this case, we can only have between 1 and 5 stars. So if there are 0 or fewer stars, we're going to say that the star count is equal to 1. And if there are more than 5 stars, then we're just going to set the star count equal to 5. So if stars greater than 5, num stars will equal 5. Else if stars less than 1, num stars equals 1. And in any other case, num stars will be equal to stars. And that would be our data validation that we employ when using the designated constructor. And note, it is not necessary to call the designated constructor. Each constructor can call the set methods directly, but in real-world applications, this is done. All of the error checking is centered in the designated constructor.